When constructing box plots, we need to know if our data set has any outliers. We define outliers as any value above the third quartile Q3 plus 1.5 IQR, or any value that is below Q1 minus 1.5 times the IQR. So we know what Q1 and Q3 are. Those are the first and third quartiles. IQR is the interquartile range, and it's calculated by taking Q3 and subtracting from that Q1, the difference of Q3 and Q1, which, if you think about it, that's exactly the length of the box, the rectangle that we've drawn. Q3, which is at the top end, minus Q1 would give us that length of the rectangle. So let's look at an example of how we would determine whether or not we have outliers in our data. And we'll just use that same data set that we've been using. So recall that in that data set we had a minimum value. Let's fix that. Our minimum value was 82. And we had Q1 of 87.5. We had a median of 91. And our Q3 was 97.5. And the maximum value of that data set was 109. So we're looking for any value that would be above, let's write this, so anything above Q3 plus 1.5 times the IQR. Well, let's figure out what that IQR is then. The IQR of this data set is Q3 97.5 minus Q1 87.5, or 10. So continuing with this calculation, we would say anything above 97.5 plus 1.5 times 10. Now you know your order of operations. We have to multiply before we can add. 97.5 plus 10 times 1.5 is 15, so that gives us an upper limit of 112.5. And now let's look at the lower limit. Anything below Q1 minus 1.5 times the IQR. So that would be 87.5 minus 1.5 times 10. Which is 87.5 minus 15, and that comes out to be 72.5. Oops. 72.5. Okay. So, do we have anything above 112.5? Well, we can look at our max and see quickly that no, we don't. If our maximum is 109, we don't have any values above 112.5. Likewise, for our lower limit, we can quickly look at our min, 82, and see that we're not below 72.5. So we can conclude for this data set that there are no outliers. No outliers. However, not all data sets, of course, will end up with that result, so we have to run through this calculation. Now I want to point out one thing that didn't happen here but could happen in an example you might work, and that is that we could end up with a lower limit of a negative number. And when you're dealing with things like the weights of tomatoes or the number of babies born in the hospital or something like that, you know that you can never have a negative number. And so that you might see that negative and think, oh, that must be wrong. But it's not wrong. If you get a negative for your lower limit, that's fine. You just report that. But understand that if your data doesn't have negative values, which most data sets don't, then you just conclude that it's impossible to have a lower limit on that. You would not have any outliers on the lower end because you had a negative value, and you can't have a negative number of defects or whatever the data set represents. So just keep that in mind, that sometimes that lower limit could be a negative number, and that's fine.